Connecting a 110 volts alternating current neutral to the safety ground is indeed a safety violation. This practice creates a parallel path for the neutral current, and this parallel path can lead to a multitude of problems, jeopardizing both equipment and personnel. Let's delve into the reasons why this is a hazardous situation. Firstly, the fundamental purpose of a grounding system is to provide a low impedance path for fault current to return to the source, thereby facilitating the quick operation of overcurrent protective devices like circuit breakers or fuses. When a fault occurs, such as a live wire coming into contact with a grounded metal enclosure, the fault current seeks the path of least resistance back to the source. This surge of current trips the breaker or blows the fuse, disconnecting the circuit and preventing electrical shock or fire hazards. However, when the neutral is connected to the ground at multiple points, a portion of the normal neutral current begins to flow through the grounding conductors. This is problematic for several reasons. 1. The grounding conductors are typically not designed to carry continuous neutral current. They are sized to handle fault currents only. Continuously carrying neutral current can cause the grounding conductors to overheat, potentially leading to insulation damage and even fire. 2. The presence of neutral current in the grounding system can create voltage potential between different grounded parts of the equipment and the earth. This voltage potential, even if it's just a few volts, can be enough to cause electrical shock if a person comes into contact with two grounded surfaces simultaneously. This is particularly dangerous in environments where people are in contact with water or damp surfaces, as water significantly reduces the body's resistance to electrical current. 3. Connecting the neutral to the ground at multiple points can interfere with the proper operation of ground fault circuit interrupters, commonly known as ground fault circuit interrupters. Ground fault circuit interrupters are designed to detect small imbalances in current between the hot and neutral conductors. If a ground fault circuit interrupter detects a current leakage of 5 mA or more, it will trip the circuit, quickly cutting off power and preventing electrical shock. However, when the neutral is connected to the ground, a portion of the neutral current may return through the grounding path, creating a false imbalance that can cause the ground fault circuit interrupter to trip unnecessarily or, conversely, prevent it from tripping when a true ground fault occurs. 4. In sensitive electronic equipment, the presence of neutral current in the grounding system can introduce noise and interference, disrupting the operation of the equipment or causing it to malfunction. This is because the grounding system is intended to be a clean, noise-free reference point for the equipment's electronic circuitry. Introducing neutral current into the grounding system compromises this reference point, leading to erratic behavior or data corruption. 5. The National Electrical Code, specifically Article 250, outlines the requirements for grounding and bonding electrical systems. The NEC clearly states that the neutral conductor, also known as the grounded conductor, should only be connected to the grounding electrode system at one point, typically at the service entrance. This single-point connection ensures that the neutral current returns to the source through its intended path and does not flow through the grounding conductors. Connecting the neutral to the ground at multiple points violates this fundamental principle of the NEC and can result in code violations, fines, and even legal liabilities. 6. Consider the scenario of a detached garage or outbuilding fed from the main house. It is common practice to run a 4-wire feeder consisting of 2 hot wires, a neutral wire, and a grounding wire to the outbuilding. The neutral and grounding wires should remain separate in outbuilding, with the grounding wire connected to a grounding electrode such as a ground rod. Connecting the neutral to the ground in the outbuilding creates a parallel neutral path, which can lead to the problems. 7. Another issue that can arise from connecting the neutral to the ground at multiple points is the phenomenon known as circulating current. Circulating current occurs when multiple grounding paths create a loop, allowing current to flow continuously through the grounding system. This circulating current can cause overheating, voltage drops, and interference with sensitive electronic equipment. 8. In some cases, connecting the neutral to the ground may seem to improve the performance of certain electrical equipment. For example, it may reduce voltage drop or eliminate nuisance tripping of circuit breakers. However, these apparent benefits are often masking underlying problems, such as undersized wiring or overloaded circuits. Instead of addressing the root cause of the problem, connecting the neutral to the ground creates a dangerous workaround that can have serious consequences. 9. In addition to the safety concerns, connecting the neutral to the ground can also create problems for electrical testing and troubleshooting. When the neutral and ground are connected, it becomes difficult to isolate and diagnose problems in the electrical system. For example, it may be difficult to determine whether a ground fault is present or whether there is excessive neutral current flowing through the grounding conductors. 10. It is crucial to understand the difference between grounding and bonding. Grounding refers to connecting the electrical system to the earth, providing a path for fault current to return to the source. Bonding, on the other hand, refers to connecting all metal parts of the electrical system together, creating a low impedance path for fault current to flow. Both grounding and bonding are essential for electrical safety, but they serve different purposes and must be implemented correctly. In conclusion, connecting the 110 volts alternating current neutral to the safety ground is a safety violation that can have serious consequences. It creates a parallel path for neutral current, which can lead to overheating, voltage potential, interference with ground fault circuit interrupters, noise and sensitive electronic equipment, and code violations. The neutral should only be connected to the grounding electrode system at one point, typically at the service entrance, in accordance with the National Electrical Code. If you suspect that the neutral is connected to the ground at multiple points in your electrical system, it is important to have a qualified electrician inspect the system and correct the problem. Ignoring this issue can put your safety and the safety of others at risk.